Okay, we're talking about signals, so I've got a little cool chart here. This is a list of some of the common signals. Hang up, which means back in the old days when you dialed up, into a terminal, and then if something happened and you hung up, that means, hey, what do you want me to do? Well, I'll probably want you to destroy everything after that. There's an interrupt and a quit and a kill and a bunch of other junk. 15 is the software termination. That's the one if you just use the kill command, which means, pretty please, will you please stop doing what you're doing and die? Okay. Now it doesn't actually. This is a little complicated. Some commands are going to be told not to listen to signals. For example, let's say I started up something and I put it in the background, and then I logged off, and I do not. Remember, I don't want the HUP. I don't want HUP to kill that guy. So is there a way you can tell the shell to, well, wait a minute now, I don't want to listen to HUP for my background tasks, only for my foreground tasks when I'm typing in. So if I start something in the background, which for example, I still have that tree command running in the background. It's not running, it's paused, but it's still there in the background. So if I logged out and logged back in, is that gonna still be there or not? Okay, that was a weird one about kill, the -9 guy. Here's the thing. See where it says can catch, right? All these things are designed to catch, and this is can it be blocked? Blocked means can an application say, screw you, I ain't listening to your dang signals? Well, the answer is yeah. You can write applications that basically say, I ain't listening to you. The problem here is the kill. You need some way of saying, look, I need to kill things regardless. Kill with extreme prejudice. And that's the -9. And so the reason why processes can't block signal 9 is because signal 9 is not sent to the process. It looks like it is. I would type kill -9, 1, 2, 3, 4, 5, and hit the return. It looks like to the naked eye that I'm sending a -9, a kill. I'm sending a kill signal to a process. I'm not. What I'm actually doing is I'm talking to, instead of talking to the tenant and saying, please will you leave, I'm talking to the landlord. So when I do a kill -9, I'm talking to the operating system, and the operating system is going to kick your ass out of the apartment, and you don't have a say about it. So the reason why 9 can't be blocked is because it's not sent there. Kind of makes sense? Okay. All right. So there's a thing called kill all. So kill by itself, give it a process ID. Kill all, if I gave it like my, what was my process? I don't remember what my process ID was. So 1873. If I said kill all, what that basically would mean is I could go in and do a bunch. Now kill all can actually, you could actually put in a name of a command rather than the number, which is pretty weird. Now the problem here is when I do kill all by name, kill all by PID, that's straightforward. I say, look, I want 1873 done. But if I said kill all bash, by the way, there's no real pattern matching here when you do a kill all. If I say kill all bash, it's going to find the word bash in any one of those things on that last column, anywhere, and say, okay, time for me to kill, boom, 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 boom. Now, luckily, if you're not the owner of the process, it's going to ignore you, right? Because you don't have permission to send the signal, right? But still, that could be a little dangerous, a little scary to do a kill all on bash. Ugh. Okay. So when we talk about process and threads state, that column where it has the capital S and little s and a capital S and all that stuff. So for example, if you look down on tree, okay, I have a T in there. Well, what do you think that means? Okay, so T basically means that it sounds like T stands for terminate, but T basically means that thing is blocked and is no longer doing anything. Now again, thread states, I'm not going to get into thread states, so we'll just stick with processes. Okay, so monitoring process on page 98. So the AUX is PSAUX, the one we've been doing. This guy is pretty decent. It's kind of has a friendly output because AUX is going to translate the numbers to the words like root, right? Instead of saying it's 1001, it says Emmett Gray. Okay, so it's designed to be a little bit more human readable. But to tell you the truth, if you were trying to measure performance, the fact that you were having the command translate those IDs, to words that you can read, kind of slows it down. Whereas, not that you're going to be able to see any difference, but if I did Axel as the second one, this actually works a little better, faster, because it doesn't have as much to do. It's a raw information and doesn't have to do much. Doesn't have to translate, process ID, owners, and all the rest of that stuff. So if I ask you, why is it faster? I say, well, it's got less to do. I don't have to look up things. Cool. On page 100, table 4.2, they give you the list of all the field names and all the explanations for all this stuff. So let's just say I want to know what the process ID of something that I'm running. One of the things you can do a PS, right, and then run it through grep and find tree. Okay, so the process ID of that is 24699. Cool, that's one way of doing it. There's another way. There's actually one called pgrep. Pgrep. Tree. And basically, pgrep is almost the same thing as what we just did. It runs a PS and pipes it through grep. Actually, I don't know if that's what it does, but the effect of it is as if you had typed PS and piped it through grep tree. And there's another one called PID of. And all these three techniques tells me the same process ID of that tree command that I've got stuck out there. Cool beans? So 3 different ways you can find the process ID of a running process. We talked about top command. Now, top command is powerful. I mean, if you ever really were going to be doing Unix for a living, you probably need to spend 20 minutes learning about the top command because it is amazing. It'll allow you to go in with the cursor and move some things around and kill off processes and do all sorts of strange things. We're not going to do any of that, but just be in awe of the top command and I'll be happy. All right? So it can use keyboard to send signals and do change priorities and lots of things. The other one is called vmstat. We showed that one before. So vmstat basically says, this is VM, so virtual machine, or actually virtual memory. How much physical RAM do I have? How much is it being virtualized? Because let's just remember, when we built our machine, when I built this one, I gave it 3 gig of RAM. Every process and every user gets 2 gig. You think, wait a minute. Well, it's not real 2 gig. It's fake 2 gig. So it virtualizes that. And if you're not using much, you're okay. But if you start using it all, the VM could basically say, whoa. And I'm not going to go through all of this stuff about swap and I/O and system and CPU. But there's a lot of good information here if you're trying to diagnose why your system is beginning to slow down. Okay. The next one on page 102 is the nice command. And this is how you go in and tell a process. I'm getting ready to start up yet another process. In fact, I'm going to create another one of the tree command guys. Okay? So if I said nice minus n 20, and then I did tree slash, okay? It helps if you spell it right. Okay, so what this is basically saying is nice minus n 20, and then yet another tree command, and I'm going to stop it just the way I did before with Control Z. Okay, so now I'm going to do PS. Actually, I'm going to do PS and then do grep tree. I want to see the whole thing. No, I want PS AUX on grep tree. Dang it. Okay. Doggone it. I want the niceness to be shown through. Axle. Okay. So the original one has a niceness of 0, and the other one has a niceness of 19. Don't worry about how it came out to 19. Here's the thing. If I want to run a command and be nice to other people, that's what nice means. Nice does not mean I want to be nice to myself and make it run faster. I want to be nice to other people. So a positive nice number, a positive number like 20 or 19, means that process is going to be running slower than the other ones. Okay, that might make sense. I'm being nice to other people. Now, I can use nice to make things go faster than usual. And here's how it would be. I would say nice minus 20. And by the way, if I said minus 20, first of all, doesn't that look a little funky? And what a lot of people do when they do this is they'll take the space out so it looks like that. Mainly because this looks like, you know how the dash is always the separator for commands? So I don't know if this one's going to do that. So I'm going to try it. Yeah, okay, it did. Whoop. Come on, doggone it, stop. Okay, cool. So minus 20, but without a space, okay? So now I'm going to do my Axel guy one more time. Okay. So, that didn't actually work the way I expected. Okay, let's try it one more time with the space like that. Oh, I know what the problem is. Yeah, okay. Yeah, the problem here is in order to make the niceness go down, the concept of down and up is a little funky here. If I want to be unnice, I basically have to have super user powers to be able to unnice something. Okay. Anyway, what I was trying to show you is negative numbers makes it run faster, positive numbers make it run slower. Okay. Whew. Typically, a process inherits the niceness from their parent. So if a process has started off with a niceness of 10, and then if it creates a child, the child's going to inherit the 10. Okay, makes sense? Now, nice is only about starting a brand new process. What if I wanted to change the niceness of an existing process? Well, there's one called renice. So renice, I'm going to pick on, I'm going to say renice, and here I'm going to do plus 10. Okay, plus 10. Well, doggone it, this is a little more complicated than you might think. Now let's do minus 10. Minus 10 on the one that has 19, which is 2, 4, 7, 9, 1. Yeah, okay. Again, I can't make it go up. I can only make it go down. Okay. Anyway, the bottom line is the renice allows you to change the priority of an existing thing. And again, I can take one and say go down in priority, but I can't make it go up in priority. And doesn't that kind of make sense? If you don't have SU powers, I don't want an ordinary user to go in there and start changing the permissions of their SQL query so that it runs faster than the login, right? I don't want that. So it kind of works. So nice and renice. The only thing complicated about nice and renice is whether or not to use a positive number or a negative number, because it's sort of like turn the air conditioning up. Up. You mean you want the temperature up, or you want the function of the air conditioning to go up? So when my wife says turn the air conditioning up, I don't know if she wants it to be colder or hotter. I have the same problem with nice. Okay, we're coming up on 15 minutes.